Discrete Math, Amazon, by the Discrete Ballers, Nia Anderson, Mark Johnson, Sean Majewitz, Aaron Zifra, and Aaron Strom.
Amazon's Supply Chain Optimization and Graph Theory by me, Sean Majewitz. Amazon was founded by Jeff Bezos in 1994, but the current CEO is a man named Andy Jassy. Amazon has become one of the world's largest and most successful e-commerce companies and has footholds in cloud computing, digital streaming, and artificial intelligence. Their current company motto is to be Earth's most customer-centric company. Becoming one of the world's leaders in e-commerce means that you need to have all of your bases covered twice over. Amazon has done this by investing and experimenting in new ways to entice their customers to buy more and to satisfy customers' needs by making their delivery experience as expedient as possible. One way Amazon does this is by using big data to gain the information needed to make graph theory a vital part of their supply chain's efficiency. Big data technology is used to analyze and manage large amounts of data. This data for Amazon's uses includes information about its customers, market insights, its competitors' marketing strategies, and Amazon's recommendation engine. Amazon's recommendation engine recommends other products that customers are likely to buy while shopping. This data helps Amazon guess what other items a user might buy. For Amazon supply chain uses, they keep track of a customer's personal information like address and keeps track of the inventory of certain warehouses close to the customer. Graph theory is used by Amazon to find the best delivery schedule possible, the best route, and the best product groupings, which would further decrease the shipping expenses and make the products get to their new owners as soon as possible. Just a quick graph theory recap. Graph theory is a branch of mathematics that creates a symbolic representation of a network by the use of vertices and edges and its connectivity. Nodes, or otherwise known as vertices, usually represent entities that are in a network and can hold certain properties like size, position, weight, degree, which is the number of other nodes connected. An example of this to the right would be the numbers 1, 2, 3, etc. Edges represent the connections between the nodes and might hold certain properties pertaining to the network, such as the strength of the connection or the direction of the relation. Examples of this would A, B, and C to the right. Undirected lines or edges go both ways, as in mutual friends on Facebook. Example, that would be line A. And directed lines. Directed lines potentially only go one way, as in someone following a celebrity on Twitter and the Twitter celebrity does not follow that person back. Example, that would be line I to the right. How supply chains use graph theory. A supply chain refers to an entire network of companies that design, produce, and deliver products. Three main components are involved, which are material, information, and capital, otherwise known as money. Graph theory can be used to solve many logistical problems that occur in the real world. Two examples would be the Chinese postman problem and the traveling salesman problem. Both of these problems are similar and use graph theory logic to solve them. The Chinese postman/traveling salesman problem are examples in which we are trying to search for a walk so that we can go through every connection in the graph only once and do so in the shortest possible way, using direct or indirect graphs. For example, the houses would be considered the nodes in the problem, and the roads/pathways would be considered as the edges. The objective is to find the shortest minimal route that reaches every node and returns to the starting point. This way, the Chinese postman/traveling salesman completes his objective while saving time and money. There are many solutions to these problems that span from being extremely simple to being released in academic papers. Some examples are brute force, calculating every possible route and then choosing the best one; nearest neighbor method, which is to simply choose the nearest neighbor and then the next nearest and then the next nearest, and then restart and then return to the start at the end. Biogeography-based optimization algorithm, which is a method that is designed based on the animal's migration strategy to solve the problem optimization. And then multi-objective evolutionary algorithm. This method is designed for solving multiple traveling salesman problems based on NSGA2, which is a complex algorithm. While these are all solutions to the Chinese postman/traveling salesman problem, that does not mean that they are the most efficient. The simple solutions are just too simple for supply chain management and can't keep up. The academic solutions are too time-consuming for supply chains to use them efficiently. Because of this, companies like Amazon use route optimization algorithms that find near optimal solutions in a fraction of the time, giving delivery businesses the ability to plan routes quickly and efficiently. Amazon has created its own algorithms for the fastest and cost-saving routes. One of them is from an app called Amazon Flex, which allows you to deliver packages from your own car. Amazon has used both discrete mathematics and graph theory in real-world scenarios to make it more efficient, cost-effective, and into one of the most successful international companies the world has ever seen. Thank you for listening.
Hello, my name is Aaron Zifra. Before we go into a deep dive of the many ways that Amazon utilizes discrete math in its applications, one must look on a higher level to see if there is any element shared by its applications. That element is data. Amazon has taken many steps in how it not only handles its enormous volume of data, but also how it protects it. There are many steps put in place to ensure that this data is available for use. At the heart of Amazon's many applications is its data centers. Since 1994, Amazon has been working with data. The first part of this evaluation is part of the physical aspect of data and how it is collected and handled. It is widely known that one of the first ways Amazon protects data is by operating many data centers. It is alleged that Amazon runs its many data centers under less identifiable names to maintain an obscure presence, unlike Google and Facebook. It is speculated that Amazon was operating in over 100 data centers in 9 countries, including the United States of America, Ireland, Germany, Luxembourg, Japan, China, Singapore, Australia, and Brazil. Only approximations of locations are given, and Amazon appears to attempt to divide up regions into zones with a minimum of 2 available data centers per zone. Each zone is connected using private fiber optic networking. From a physical aspect, Amazon protects its data centers with security. This can include fencing, security guards, security feeds, intrusion detection technology, and door alarms. Amazon restricts access to these data centers to only people who need to be at the location for a specific business reason. This is controlled by an application process and reviewed by an access manager. Once the specific work is completed, the access is revoked and an employee or other must start the application process again. Once a person is granted access, they are issued a specific security card that works using multi-factor authorization. This security card will allow them access to only specific areas needed for their work via a series of card readers. Amazon has also chosen each site of for data centers based carefully on consideration to mitigate environmental risks such as flooding, extreme weather, and seismic activity, to name a few. Amazon also utilizes automatic sensors and responsive equipment to monitor each data center location. Amazon also has a business continuity plan which tests each location with drills to simulate different environmental scenarios that are relevant to each location. Once inside a data center, Amazon has developed an infrastructure layer. This includes components such as backup power equipment, backup water supply, telecommunications, backup networking, HVAC systems, and fire suppression systems. Amazon has also set up a robust plan to consistently run diagnostics on all equipment. networks, and backup systems to ensure proper working order. All areas within data centers are both temperature and humidity controlled to reduce risk of overheating. Amazon data centers have strict control of equipment used in their facilities. Strict policies have been established on how to install, service, decommission, and eventually destroy each device when they are no longer required. Finally, Amazon maintains control by requiring that equipment is audited by external auditors throughout the year, and it is checked over with 2,600 requirements. These audits ensure proper compliance with both internal and external regulations. The second part of this evaluation is how data is actually protected within the computer world. Amazon utilizes two main schemes to protect its data. They are encryption and tokenization. Both tokenization and encryption are used to secure and protect data and information. They are both high-level forms of discrete mathematics. Tokenization is a process that allows a token to be defined to represent a sensitive piece of information. This token is considered to be meaningless on its own and is not derived from the actual data. An example of this is to define a token instead of a credit card number to be used on a website. This token is then used to process the transaction instead of continuing to use the actual credit card number. This helps to reduce risk and maintain compliance. Encryption is another method that changes its content in a way to make it unreadable without a secret key. This secret key is necessary for any attempts to decrypt the content into plain text. Amazon has been able to define an approach to encryption that includes storage, rotation, and access control of keys. Now that we have a background on all the steps necessary for Amazon to maintain data, we can look at the many ways Amazon uses this data for discrete mathematics.
One of the reasons Amazon is such a successful corporation is its ability to cut costs and optimize the packaging process to become as efficient as possible. Each package starts at one of Amazon's fulfillment centers, which is a more complex process than one might think. The 185 warehouses globally are split up to handle either sortable or non-sortable goods. Sortable items are any item that can be stored and packed easily, while non-sortable items are larger packages like appliances or furniture that require special shipping. Focusing on the fulfillment centers that handle sortable goods, Amazon has developed a robotic system that cuts costs, as well as the time it takes to process and ship these packages. Formerly known as Kiva systems, these robots utilize a variety of discrete mathematical operations to ensure productivity and efficiency. The Kiva systems are small robots that move about the warehouse, lifting storage shelves and moving them to a worker who will retrieve the product ordered. The layout of the warehouse is programmed into these robots via 2D data codes attached to the floor. Utilizing graph theory and the concept of walks, these robots move about the fulfillment center with minimal traffic. The shelves are often packed closely together, which requires other shelves to be moved first. This is handled by programming the systems to move the shelves about in the least number of steps. Once the unit reaches the worker, the shelf lights up indicating where the item is located. This method helps reduce the time it takes for a worker to retrieve an item from the shelf and eliminates the need to search each shelf for the product. Amazon is also working on a new generation of Kivas, nicknamed Hercules. This new generation of Kiva will require fewer resources to manufacture and will be smaller to carry more products each trip. They will also be developed to be even smarter, processing the back-end software quicker. Behind the scenes, Amazon uses an engine called Amazon Fulfillment Technologies, or AFT. This is what drives the fulfillment process virtually as well as physically. AFT uses machine learning, image recognition, translation, and more to process the millions of orders coming through each day. Discrete math and machine learning are used to manage shelves that have been picked from and sent to packaging. Amazon uses image recognition to determine what items are on each shelf and the quantity left in stock. It can also tell when an item has been misplaced on a shelf, which reduces the possibility of error when an item is being picked. A dataset with hundreds of thousands of images is used by machines to learn how to correctly identify each item. Another key aspect of Amazon fulfillment technologies is the Amazon Aurora database. According to the AWS website, Amazon Aurora is up to 5 times faster than any standard MySQL database. Relational databases use logic, graph theory, and many other concepts made possible by discrete mathematics. Computer systems use all this information to decide which Kiva to activate and what route it should take. Even while the Kiva is in motion, the system is constantly checking for quicker paths to the destination. It does this using artificial intelligence that improves itself when more information is received. It considers other Kiva's routes as well as truck routes and how much space is left in each truck. Amazon benefits immensely from AFT since each time it is updated to one system, all systems globally will also receive it. This creates consistency throughout the 185 fulfillment centers, and operations do not need to stop when something is changed. Every single step of the Amazon fulfillment process relies on discrete mathematics. It is the sole reason Amazon is one of the quickest delivery services in the world, since each step relies on technology founded by these concepts. Packages are shipped within a few hours of the order, which would be impossible a few decades ago considering the current scale of the company. These systems reduce the cost and time it takes for an order to be processed and shipped to your door. Some worry that this will destroy jobs, but it will open the opportunity for new IT positions to operate this evolving technology. Amazon is continuing to improve AFTs, finding new ways to incorporate discrete mathematics into the industry, as well as utilizing AI in the workforce.
Hello, my name is Aaron Strom, and I'll be highlighting the use of discrete mathematics in cloud computing, such as AWS or Amazon Web Services. Cloud computing, in simple terms, is just the delivery of on-demand computing services. Those computing services vary from applications on a remote desktop to storage of large and/or sensitive data, or even just processing power. Users can access these services over the internet and pay for them by the provider. In a nutshell, cloud computing makes it so that the end users do not need to store data locally or even have high-end computers, as they rent the ability of those services from the provider. There are several cloud computing providers such as Microsoft Azure, Google Cloud, Oracle, IBM Cloud, and AWS. The one we'll be focusing on for this project is AWS, and we'll highlight how Amazon uses discrete mathematics in their cloud computing. AWS is Amazon's cloud platform that offers cloud solutions to businesses and individuals around the world. AWS offers more availability zones than any other competitor on the market. Along with their ability to provide services for more people, they also provide a higher quality and more diverse range of services as well. Beyond even the availability and variety, AWS hosts the most secure platforms that meet even the strictest of military standards. Any discrete mathematics that are used in computing are deployed by AWS, as they provide the same computing via the cloud, just without the local physical hardware for the end users. The most glaring use of discrete math in cloud computing, such as AWS, is the use of algorithms to solve the problems they face. Algorithms such as classification algorithms, which are used to categorize data into a class or category with the use of tools such as a decision tree. Self-learning algorithms, which are algorithms that are programmed to refine their own performance. Evidence theory, which is similar to rough set theory, which addresses inexact, uncertain, or insufficient data. Predicting algorithms, which are used in machine learning with the use of tools such as random forest, which is multiple unrelated decision trees mentioned earlier combined, evolutionary algorithms, and fuzzy logic, which is an algorithm used to handle the concept of partial truth, values between 0 and 1 in Boolean algebra. The use of cryptography and encryption that are used in cloud computing are heavily reliant on discrete mathematics, and without it, these cloud platforms would not be able to provide the security that they do. AWS uses encryption for a large number of their users, and their users rely on this to know that their information and data is safe. AWS deploys the use of IST230 encryption, which allows users to protect their data with a secure key. If the data is extracted maliciously, as long as the secure key is also not extracted, AWS estimates that it would take at least 1 trillion years using current computing technology to crack the encryption. AWS uses data centers across the globe to store data for their users to access on demand. At a root level, all data centers and the data they house rely heavily on a multitude of discrete mathematics principles. From Boolean algebra, logic, and number theory, to counting, probability, and graph theory, all these principles are required to generate, maintain, and secure data for the millions of AWS users globally.
Amazon Go debuted in 2016 and were taking customers in early 2017. The idea for the store, though, began 4 years earlier. Amazon is an ever-expanding empire whose early ideas were surrounded by e-commerce, specifically selling books online. And today, they also sell commerce through brick-and-mortar stores. Amazon is a tech giant in its industry, from e-commerce to cloud computing. So where does Amazon Go, a brick-and-mortar store, fit in the company's portfolio? Amazon Go was birthed from the concept of walking into a store, grabbing what you want, and just going. These stores are jam-packed with technology, which Amazon believes will lead to a trend in cashierless stores. Consumers benefit from no lines, no checkouts, and no registers. Patrons enter the store with the Amazon app on their mobile devices, start shopping, and can just leave when they are finished. Okay, but nothing is free, so when do you pay? After leaving the store, you will be charged and given a receipt through the Amazon app. Your every movement is tracked within the store to make this possible. Amazon carries advanced technology which Amazon has named Just Walk Out. This technology is jam-packed with other emerging technology and utilizes some very important discrete mathematic concepts to bring this idea to life and to be usable by consumers. Amazon Go, a store that allows customers to enter, shop, and leave without ever seeing a cashier, holds an enormous amount of technology. From emerging technology to everyday physical devices, with the store watching your every movement, from everything you pick up, put back, and the way you shop. As one can expect, Amazon Go stores hold lots of cameras. Upwards of 100 plus cameras can be found in one single store. Cameras are a necessary part of the store, but the store wouldn't exist without some powerful software. Just Walk Out technology by Amazon is largely comprised of artificial intelligence, machine learning, and computer vision. Artificial intelligence began in 1950 when Alan Turing questioned, "Can machines think?" This question propelled AI and led to the development of machine learning and computer vision, both vital to Amazon Go. These technology work together to train Amazon Go machines what an item looks like and read necessary code to charge you when you walk out with the product. Because there is more than one person at the store at a time, the software has also been built with person identification so you will only be charged with what you pick up and not the person next to you. Amazon Go was built with computer vision, deep learning algorithms, and sensor fusion, and these components were built with several discrete mathematic concepts. Amazon Go stores are posed to be the future of the way we shop. Soon are the days where we can enter a store, take the things we want, and leave. These stores may not just be an Amazon Go store, as Amazon sells their Just Walk Out technology to other businesses as well as use it themselves. Amazon Go is powered by Amazon's Just Walk Out technology. Amazon's Just Walk Out technology was made with artificial intelligence, machine learning, computer vision, deep learning algorithms, sensor fusion, and more emerging technologies. The powerful Just Walk Out technology is powered by several discrete mathematic concepts. Linear algebra carries importance in AI through matrices. Data is one of the most important assets of technology, and the data used in Amazon Go stores use matrices to store data waiting for execution, like tallying up the things you pick up in the store and sending the receipt once you leave. Amazon tracks how users act in the store, leading to probability theory. You are a random event, and it wants to learn to predict your shopping patterns. This begins with probability. Algorithms are heavily used in Just Walk Out technology, and these algorithms begin with discrete mathematic concepts such as logic, functions, recursions, and graphs. Recursion has particular importance in ensuring the items one is charged for is the ones they and not another person walked out the store with. Once taking a deeper dive into Amazon Go, the Just Walk Out technology, one can see how prevalent discrete mathematic concepts is and will be to this new concept of shopping with no lines and no checkout. No, seriously.